Hello, my name is Edward Scott, and this is a research presentation for PCB hardware security. So, here's a table of contents of what we're going to go over in today's presentation. So, PCB assurance, and what is it, and why do we need it? So, printed circuit boards, or PCBs, are major components of everyday electronics. This means that they're also at risk from malicious hardware and piracy. There are such examples such as the Big Hack, which was uncovered by Bloomberg, where Chinese government put in malicious implant that provided attackers for remote access. Also, intellectual property thieves are using reverse engineering for profit. So it's difficult to verify authenticity in a non-laborious and cost-effective way, which is what we're trying to figure out. So the Big Hack claim, is it true or not? Bloomberg claims that there's a hardware implant, as you can see by this red circle, in certain server board PCBs, but the Big Hack PCB that we purchased in the lab did not have such implant. However, the still possibility exists that this could happen, so we need to be prepared. There are a couple of available methods for PCB assurance: reverse engineering, X-ray tomography, digital optical microscopes, and imaging using a DSLR camera. We'll talk about these. So what is reverse engineering? You have to fully disassemble the PCB to verify its security, and you can also view layer by layer by chemical etching, which exposes hidden layers. You can also take images each layer. Unfortunately, it is destructive, completely destructive, also laborious and expensive and time-consuming, and it is used by intellectual property thieves to profit off of someone else's innovation. So it's some more non-destructive analysis. What are advantages of them? Well, as the name, they are non-destructive, so you can use the PCB still, and then we can use many imaging methods. You can also incorporate different algorithms for different purposes. Some available imaging types we have in the scan lab are using a digital optical microscope, DSLR camera, and X-ray tomography. So, what is X-ray tomography? It captures 3D images of the PCB using X-rays and allows for each individual layer of the PCB to be pictured. So the end goal is to automate this process using software to detect these malfunctions. However, there are a few drawbacks of it, including that it can't provide high-definition surface images, which is why we use a digital optical microscope to take pictures for this. So it takes multiple pictures of the PCB, and it uses a separate software to picture them together or piece them together to make one large image. Me and my advisor purchased an audio amplifier PCB to perform both X-ray and microscope inspection. However, with the virus, we weren't ever able to get these images for either method. So this is an example of a separate sample, and these images will be pieced together in a later software. So in my future, the goal is to analyze and image the PCB that we acquired, the stereo audio amplifier. We purchased it. It's an Adafruit audio amplifier, and our goal is to perform X-ray imaging and digital optical microscope sketching. Unfortunately, I guess as I mentioned, it is under halt due to COVID-19, but we'll continue this in the future if this permits, if time permits. As well as in order to evaluate if certain algorithms are used or able, as well as our future work, in order to evaluate if certain algorithms are able to identify certain defects, we want to use a data set for FICS PCB database using 6 different Arduino PCB purchase and create manually tampered PCBs by taking hidden components or missing components, different pins, and have one golden sample that is a good, and one golden sample that has nothing wrong with it, and see if we can use algorithms to find out what is wrong with the PCB. So in conclusion, I feel like I can put the knowledge that I've acquired to use my focus in audio engineering with hardware, which is what I want to spend my career in. And I plan on continuing research if I'm able to, and widening my understanding of PCB assurance. And I'm also open to expand my knowledge into the more of the software side instead of just the hardware. So thank you very much for this opportunity to do research.